This video is the fourth of a series intended to explain the fundamentals and use of root cause analysis in food safety management, specifically the HACCP system. The main idea is to explore the elements of hazard analysis and critical control points, or HACCP, where principles of root cause analysis, or RCA, can be applied. The potential for utilizing components of RCA or conducting a complete analysis to facilitate the management of food safety issues has been noticed in at least 5 elements of a HACCP system. Before getting into the details, let's review some observations made while reviewing the concept of RCA. The RCA principles of the Ishikawa method may be the most useful in food safety management because they were designed to simplify the analysis of complexity. For example, the Ishikawa method helps to organize the brainstorming of causes by using categories and simplifies the discovery of the causal chain with techniques like the 5 whys. The number of categories of causes varies, but 4 of these categories are considered work elements, sources of variation, or noise factors. 2 of the 6 categories can be grouped to make 5. The big problem may be that it does not consider the science of how things work to discover root causes. Some methods recommend using the concept of contributing factors to supplement the analysis. Understanding contributing factors, especially from a causal mechanism or failure mechanism perspective, can facilitate the identification of root causes. Now, let's go back to the first HACCP step, prerequisite programs or PRPs. Their number could be reduced to a reasonable number by reorganizing their information using the Ishikawa categories. This could be done by categorizing each item listed on each program list or categorizing the programs as a whole. Fundamentally, each practice should address a cause. In the author's opinion, the difference between causes and practices is that causes address the question of why, and practices the question of how. Examples of how 5 PRPs could look after reorganization are listed on the screen. HACCP's 4th and 5th preliminary steps are related to creating a flowchart. At this stage, identifying changes in the work elements or Ishikawa categories can help with a better hazard analysis. The most important HACCP principle is the hazard analysis. Pairing food safety hazards with food materials and production steps requires good observations in the flowchart and specialized knowledge. Some tools like the IAFP-CDC contributing factors were initially created by epidemiologists to assist in developing HACCP plans. The knowledge collected in these tables can provide a good start. Managing the pairs of hazards and steps can be further facilitated by identifying at which work element they occur. Identifying work elements can ease redistributing the controls after the risk analysis is completed. The team may decide to control some hazards with simple PRPs and others with operational PRPs. Listing the work elements in the hazard analysis can facilitate their association with root causes, contributing factors, or causal mechanisms. Identifying the causes can help to find better controls. From the author's perspective, the hazards answer the question of the what, the causes of the question of the why, and the control measures the question of the how. 4 of the 7 principles of HACCP are about critical control points, or CCPs. These points are critical to control because they are implemented to reduce food safety hazards to acceptable levels. The 3rd and 4th principles are related to monitoring critical limits. The conditions for keeping the process under control are established at these steps. The 5th principle is about defining corrective actions for deviations from critical limits. The idea of these corrective actions is to put the process back in control. Ideally, corrective actions should be predetermined or proactively identified, but sometimes an RCA will have to be conducted reactively to identify the cause of the deviation. This requisite requires a good understanding of the operation and how changes in it affect the outputs. Outputs include the food material and the control data produced by the monitoring system. This is a great opportunity to illustrate how a hazard reduction step will look in a process FMEA. The function of the step is reducing pathogens. The failure modes may include variations in limits. The effects can be described at the process or consumer level. Causes can be identified to determine appropriate actions on the system and material. It is important to mention that in the FMEA procedure, the term actions refers to recommended actions to improve controls. Some food-related publications use the term corrective actions instead. Theoretically, the term assignable causes can be found in the study of statistical process control. The idea of assigning causes was used by Walter Shewhart, who pioneered the use of control charts. The second video of this series overviews how monitoring trends is an evolving field. This idea can be related to the work of Western Electric and Lloyd Nelson, who used a manual detection system. Corrections and corrective actions are essential for the maintenance and improvement of the HACCP system. Recent HACCP guidelines list corrective actions as necessary for practices and procedures. Practices and procedures range from good hygienic practices that are prerequisite programs or PRPs to CCPs. Implementing corrective actions on the food material or products depends on the case, but predetermined actions on the products are necessary for CCPs. Making a difference between corrections and corrective actions may depend on the regulations. Some RCA experts relate these concepts to the Heinrich pyramid of incidents. There is a family of pyramids related to Heinrichs, and they illustrate the relationship between near misses and fatalities. The idea is to prevent fatalities by reducing the number of near misses. Simple or predetermined corrections can be implemented when the cause of the problem is readily known. A complete root cause analysis may need to be conducted when the root causes are unknown. Recording corrective actions may be more important than recording observations. This is not only needed to meet compliance requirements, but also to collect data to make improvements in the system. In summary, understanding how RCA and HACCP are related can be useful to integrate new food safety issues into the food safety management system. The concepts of categories of causes, contributing factors, and FMEA can be used in the design and management of a HACCP system. Thank you for watching this video. The author will be happy to collaborate on projects related to these ideas.